Good morning, class. Unit 5, Lesson 2 is on obtuse and reflex angles on the unit circle. So some key takeaways that you should take from the whole lesson is on cast and what sine theta, cos theta, and tan theta can be represented by in terms of x, y, or r, where r represents the radius. This is our unit circle, and we call it a unit circle, and we say that the unit circle has a radius of 1, and we try to grab information based on that. So step by step, let's try to go through the definition. So the first definition we have is the terminal arm. So the terminal arm is the arm that rotates around the circle attached to the origin. Okay, so let's back up a bit, and you need to understand how to read this unit circle. So what I mean is, if you were just looking at a coordinate plane, and you might think, okay, so I am kind of familiar with being able to identify it as north, east, south, west. And from your prior knowledge, you would just go this way, right? In a clockwise rotation. That would make more sense because of our understanding of the bearing. So it's a way of defining direction as an angle measured from due north in a clockwise direction. But this is not the way that we interpret it when we are dealing with trig. So it's a different way. And what happens is that instead of reading from the north part, which would be here, you would actually start from here. That is our point of reference or the initial position. And so what the terminal arm is that, let's say I have an angle kind of anywhere on this unit circle, and I'll put it here for now. It's called my terminal arm. So this has shown you that the arm rotates around the circle and it's attached to the origin, which is right here. And what happened is I have drawn a terminal arm so I could start talking about an angle from there. So instead of, again, going from north and clockwise, there's a bunch of definitions to go over, but this is my starting point. That black line represents my terminal arm. So let's go through it. You have the initial position. This is the 0-degree angle. So 0-degree angle is at positive x-axis. So as you can tell, this is the x and this is the y, and it's as if we drew a circle right where the center is at the origin 0, 0. And we would say that this is the initial position. So this is like our little new north. Okay, this is our starting point. Next, let's go through it. So because I have some prior trig understanding, I kind of automatically went counterclockwise from the initial position, and that might have not made sense to you, right? When we're dealing with trig, we are going to say, if you're actually going counterclockwise, that is the positive angle of rotation. And so if I draw a small angle and it's represented by this little angle, and I have like a positive 15-degree rotation from the initial position right here, and I go counterclockwise, that is represented by positive 15 degrees. Okay, and meanwhile, as you might guess, well, if going counterclockwise is positive, then if you go the other way, that is the negative angle rotation. And this clockwise rotation is a negative angle rotation. So we talked about the first four, now to the coterminal angles. So coterminal angle is if you add or subtract 360 degrees, you land on the same coterminal arm. Let's interpret that for a second. So initially on my unit circle, I drew 120 degrees. And what I mean is a full circle is how many degrees? 360, right? So if I have 120 degrees, what's going to happen when you're kind of like on the Ferris wheel, let's say, and you are right there in position, and then you make a full circle? Well, you're going to arrive right at the same position, right? So basically, you can always add or subtract 360 because it means that you're really in the same position, but you now have a different number to represent that. And so we call that the coterminal angles. Okay, so for example, if I did 120 plus 360, that's 480 degrees. So that is my coterminal angle for 120. If I do 120 minus 360, that is equal to negative 240 degrees. So I could have represented 120 degrees with coterminal angles and 380 degrees. Next, I have the standard position. It's to begin rotation at positive x-axis in counterclockwise direction. It's really similar to initial position because initial position says, well, that is initial position. 0 degrees is at positive x-axis, so they're really kind of the same thing. The principal angle. So by me drawing this 120 degrees, see how 120 degrees is in between 0 and 360? That means that is my principal angle. I have the related acute angle or the reference angle. So the definition of that is the acute angle made with the x-axis. Important, it's not with the y-axis. It's not the acute angle made with the y-axis, but the x-axis. So for that example 120, I'll zoom in over here for a second. What's happening is, well, keep in mind that if, let's say this is 0 degrees based on what my initial position is, let's go through it. Well, from here to here, how many degrees is that? It's 90 degrees. Here to here, another 90 degrees. So 90 plus 9 is 180 degrees. And then you add another 90. 180 plus 90 is 270 degrees. And if you make a full circle, you could also say it could be represented by 360 degrees. So with that information, what would be the related acute angle for this principal angle? Well, if you look at this tiny acute angle, how would you calculate that? You would do 180 minus 120. And so these parts, which is simple to create, really tell me what to do and how to find that related acute angle. So what I was saying before is I don't want to say my related acute angle is, let's say, 30 degrees. That's not it, because that's to the y-axis and not to the x-axis. So I'm going to write that the related acute angle is 60 degrees. Next, I'm going to go to the quadrants. So some of these parts hopefully seem like review to you or doesn't seem like completely new. The quadrants, so the quadrants are, and this is the way you order them, right here is the first quadrant. And remember, this is the quadrant that the x and y values are positive or negative. They're both positive. Okay, meanwhile, let's go to the second quadrant. We go again counterclockwise. It's where my y values are positive and my x values are negative. That you can keep that in the back of your mind for a second. For the 3, that's the third quadrant. And that's where, let's see, the x values are negative and the y values are negative. Meanwhile, for the fourth quadrant, I have, that's the location where my x values are positive, but my y values are negative. This information will help us later on when we're creating the cast rule. And so this is my 0 degrees, the 360 degrees, 90 degrees, 180 degrees, 270 degrees. Next, let's go to the acute angle. So what are acute angles? Acute angles they're the really cute ones, right? They're the ones that are between 0 and 90 degrees. Obtuse angles. Obtuse angles are a bit bigger and it's between 90 and 180 degrees. Meanwhile, the reflex angles, you might have not heard of those, is the angles that are
above 180 degrees and below 360 degrees.
So I'm going to switch that up actually and write 180 degrees to, it's between 180 degrees, but not beyond 360 degrees. And at first you might be like, well, how can you have an angle larger than 360s in the first place? But remember how we had the 480 here? And what that meant is I just did one more rotation after that and I added that to it. Okay, so that is all the definitions we kind of need to warm up to all these kind of questions. 2, it says state the principal angle and the related acute angle. Then state 2 or more coterminal angles. Okay, you look at that first question and it says A is negative 220 degrees. That might look odd to you. So the first thing I try to do is try to calculate my principal angle. And if you look back at the definition, it says that the principal angle is when you have an angle that is between 0 and 360 degrees. So when you're on like that Ferris wheel and you're at this position, this way, plus 360 degrees, and then I would be at a value that is in between 0 and 360. There's no point of me, let's say, going more negative because then I would have an even larger negative value because a negative and a negative adds to a higher, even bigger negative number. And so my rule of thumb is that I am going to add or subtract 360 degrees, a full resolution.
What I meant to say was revolution, because that represents like a full rotation around the circle. A resolution is like a resolution to a problem.
Until the angle is between 0 to 360 degrees. And so I am going to write down my work, which is I did negative 220 degrees plus 360 degrees. Do you have to show your work on that every time? Probably not. I'm just showing you this time so that you know what I'm thinking in my head so that I can conclude quickly that principal angle is equal to 140. Okay, the question that said find the principal angle, the related acute angle, and then state 2 more coterminal angles. So let me find that related acute angle. So for now, I'm going to state that these are the following angles at those axis points. So if that is the case, if I have negative 220 and for the principal angle I had 140 degrees, well, do you see it? Well, you're going to be doing 180 minus 140 to get that related acute angle, and that's going to be equal to 40. So you're realizing that 140 plus 40 is equal to 180, and so that part is 40 degrees. So it's the part that is beside the x-axis. Angle is equal to 40 degrees. So again, a really common mistake with the related acute angle is you want to be right beside the x-axis. People will write, let's say, 50 degrees. That's not it. It's a big, 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 big no-no. You have to write the related acute angle that is attached beside the x-axis. That is the related acute angle, not the ones attached to the y-axis. Those mean nothing to me right now. Okay, next, let's find the coterminal. And tip is that use angle provided and not the acute angle. The related acute angles help us solve other things in the future, but in terms of stating what our angles are, it's not needed right now. So remember, the coterminal angle, that's my Ferris wheel example. I can rotate another 360 degrees or go back 360 degrees and get my answers. So what I'm doing is, well, if I have original, which is negative 220 degrees, I could subtract 360 to it. I already added 360 to it to get the principal angle. So one of my option is that to my 220 degrees, which is the original angle, I am going to subtract another 360 to it, and I will get negative 580 degrees. So that is my first coterminal angle. Next, if I'm writing it as a list, you could go straight to go straight to this. That's fine as well. Just showing you what I'm thinking in my head. So I have, let's say, the negative 580. With the one you just got, you could add or subtract another 360. Well, if you add 360, you'll be going back to negative 220. So I'm going to subtract another 360, and I get negative 940 degrees. As you can tell, you can basically add and subtract 360, you can keep going, and you can create an infinite list of these coterminal angles. Next, I'm going to go back to my principal angle, and my principal angle was just my negative 220 plus 360, right? And so I'm going to do 140 degrees, which was my principal angle, and add 360 to it. When I do that, I will get an angle that is outside of my principal angle. It's outside of my 0 degrees to 360 degrees. When I add that up, I will get 500 degrees. Next, I will continue doing that. So I got 500 degrees just now. So to my 500 degrees, I will add another 360 degrees, and therefore I will get 860 degrees. So this is how you find the coterminal angle, and you might be wondering, why do you do this? Why are we stating these? And this is generally how I think of it. Generally, we're dealing with the principal angle and the related acute angle, and we're usually working within this domain of 0 to 360. But sometimes in questions, they might ask to provide more angles that are possible if the domain was extended, and that's when you would provide these extra ones. That's usually where the coterminal angles are relevant. So let's take a look at question B. Right now we have 615 degrees, so there were multiple rotations of 360 degrees until you arrived at 615. So remember, my rule of thumb was to add or subtract 360 degrees, the revolution, and you're going to do that by rotation. I'm at 615 degrees, which is obviously very large and higher than 360 degrees. So rather than adding 360, I'm going to subtract 360 and see if I arrive at an answer that is below 360 degrees, but higher than 0 degrees. So therefore, this is my principal angle. And therefore, if I drew that out, remember, I'm going to start from my 0 degree position. I am going to go from here to here. That's only 90 degrees. You're going to move another, that's 180. And I know it's not yet at 270, which is there, but instead of doing that, 0 to 90, 90 to 180, and then 255. And that makes up my principal angle. So let's find the related acute angle. My related acute angle is going to be found by looking at what is that related acute angle that meets the x-axis. So if this terminal arm is telling me that that is 255, well, I'm not going to subtract with 270 because that's to the y-axis. And so you're going to subtract 255 by 180. Notice that the order that you add matters, right? So I'm going to do 255 minus 180, not 180 minus 255, because that way I would get a negative related acute angle, and related acute angle should always be positive. And so I'm going to write 255 degrees minus 180 degrees is equal to 75 degrees. And therefore, on my drawing, that is my related acute angle. And so that's why the visual really matters and you're understanding what's going on visually. Because it's not a very good idea to like try to memorize, oh, I add 180, I subtract 180, I'm going to do this and that. But look at the picture, right? If you have the angle at 255 degrees, well, I'm not going to do something with a 270. I'm going to do it with respect to this line. And if from here to here is 180, that means, well, if I do 255 and I take away that 180 degrees, see how that part is now going to be my related acute angle. Keep in mind, this is going to take a lot of practice and you got to like look at the visual and make sure everything kind of makes sense because it's a matter of practice. So just make sure that the related acute angle is always positive. Coterminal angle, what I need to do is just to add and subtract 360 degrees to my original angle. Terminal.
Since coterminal just means lying on that same terminal arm, that's why I'm writing 615 degrees as one of the coterminal arms.
So from there, I'm going to add and subtract 360. 255 minus 360, I will get negative 105. When I do negative 105 degrees, subtract by 360, I will get negative 465 degrees. 15 degrees plus 360 degrees, I get 975 degrees.
And there are infinite number of coterminal angles.